If this conversation hits home for you, the best way to support the show is to follow, share, and leave a quick review. I really appreciate you guys so much. On to the episode.
3 out of 10 times in baseball, and you do that long enough, you're a very well remembered baseball player.
Welcome to another incredible episode of Purpose Driven Progress. As always, I am your host, Jacob Hicks. And today, you guys, man, we've really got a fun one. We're going to be kind of diving into the deep end a little bit. I'm not going to lie. Because today we've got James Jimmy Bosco. He's a former pro baseball player turned scientist, entrepreneur, and advisor. From the Orioles and the Cardinals to cutting-edge biotech labs, Jimmy brings a rare blend of grit, curiosity, and bold experimentation to everything he does. Jimmy, my friend, welcome to the show, man. So glad to have you.
Thanks, Jacob. Glad to be here.
Well, let's kind of start at the top of the thing here. So, I mean, gosh, there's a ton to unpack there because you're a pro baseball player and now you are like huge in the biotech world. So, I mean, how does that kind of all mesh together? How did you get to where you are?
Yeah, so I started by getting drafted by the St. Louis Cardinals. And in college, I had a rather circuitous route because of a lot of complications. I originally started at UC Berkeley, Cal, for baseball on a scholarship. And I moved to the University of Arkansas in the SEC for baseball in 2010 because of budget cuts in California. They were talking about dropping the baseball program, and rumors were flying around. So we decided that we were gonna move out there, and ultimately that was because I was focused intently on baseball, and I had some success. Arkansas had come to town, and when Arkansas had come to town and we played against them, I had some success on a Friday night against their best pitcher. And ultimately, that was something that really allowed them to say yes to me coming and playing with them. And it was a great time in Arkansas. Played in the College World Series in 2012. We finished third in the nation that year. And then ultimately, it was starting to become clear that when we were there, meaning me, my family was a big part of that too. So I feel like we, they thought that it was clear that these guys were not going to let me play every single day in a way that would enable me to be able to go professional in baseball like I knew I could.
Okay.
Came back to Menlo College for one semester in 2013 spring after being in Arkansas. And Menlo is a small college right next to Stanford and Palo Alto area. And I was drafted out of there. And, you go play professional baseball, it's going to be a mix of a lot of different things. And I had a lot of success in my career. And ultimately, it wasn't up to me in many cases where the decisions were going to be made for my career itself.
Right.
My first year, I had a lot of success. Had a lot of success every year. But I wanted to switch gears and go back to school. And because I had this journeyman long circuitous route across college at that point, I decided, we can go back to Berkeley and I can get my degree. And at that point, I was a father. My wife and I were thinking about moving back to the Bay Area for me to do that. And when I got back there, I had some of the biggest breaks of my life because of baseball, having met some incredible scientists and folks that were just very, very top tier scientists. And ultimately, it was the background in baseball that enabled them to really be excited about me being in the lab.
Yeah. Yeah. So you were telling me the story, right? Well, do you mind sharing that conversation that you guys kind of had? I mean, when you were doing some of those, those lab interviews. That's a fun story.
Sure. Yeah. It's funny to think about all the way that it went down. I first scientist I ever spoke to when I got back to Berkeley was Jennifer Doudna. Jennifer won the Nobel Prize in 2020 for CRISPR-Cas9 technology. Her lab was ultimately full, and so I reached out to several other laboratories that I was interested in working with. And at that point, I was more interested in doing medical school because my father's a trauma surgeon, my mom's a nurse. And so it was familiar. And when I reached out to several of these folks, I got some favorable responses back because I was very honest. And, if I could say anything to anyone out there who's a scientist, who's wanting to be an aspiring scientist, I would say that, you ultimately want to be honest about what you know and what you don't know, because I said, I don't know anything, guys. I don't know anything at that point, but what I do know is how to be in close proximity to people for a very long period of time in a row constitutively because of baseball. I knew how to be a team player. I knew that you needed to make adjustments consistently because things fail. Baseball's got a high failure rate. And that drew the attention of Robert Tijan. And so I got my I got my big break when I met with Tej in his office. I walked in and, you know, Tej's office is an impressive place. And I had no idea who he was at the time. And, you know, there's a picture of the president in the office with him next to him on the side of the table where I was looking. And there's the Golden Gate and the whole view of the San Francisco Bay Area. You know, it was like Iron Man's office, right? And I'm
Yeah,
like,
yep.
who is this guy? And, he said, after about 2 minutes of small talk, here's the deal. You're going to come in my lab and you're not going to know what the hell's going on. And then some time is going to pass and you're still not going to know what the hell's going on. And then you'll take some classes and you'll be 5 more minutes into our lab meetings before you're completely lost. But none of that's why I'm bringing you into my lab. I'm bringing you into my lab because you were the 1% in baseball. And that's a universal trait in your life. And now we're going to do it again with science. And I was hooked.
I love that. That's so much fun. Before we get into like all the cool, I mean, like you already mentioned CRISPR and some of these other things. Well, I guess first, before, like for anybody who may not know, can you just explain briefly like who Robert Tejan is?
Sure. Yeah, Robert Tejan discovered in many cases in most of our textbooks transcription and how genes turn on in our cells. He's credited with the first discovery of a transcription factor of all time during his postdoc training with James Watson. He calls him Jim. So James Watson is kind of my proverbial academic grandfather, if you will. So James Watson discovered DNA, the structure of DNA with Francis Crick. And then Robert Tejan discovered the first transcription factor of any sort in his lab when he was studying there as a postdoc. And then he came back to Berkeley and became a professor at Berkeley in about 1978, 1979. I think it was 1979. And he quickly became a face that was a force to be reckoned with back on the West Coast, having become a original scientific advisor for Genentech. And he's a serial entrepreneur himself now, founding Tularic with one of his good friends, David Goodell. And they ultimately sold that company in, I think, 2004 to Amgen for $1.3 billion. And he's now a part of many other biotech ventures. He's a director, or has been a director to the Column Group. And I think he won California Scientist of the Year at one point. And just a good man in the lab, good human being. You would never know, having talked to Tej, what, you know, everyone calls him Tej, what his background is, but he's incredibly formidable in the lab, an intense scientist, and only intense because he wants the rigor that brings the ethical, wonderful results that people need that will eventually lead you to the clinic and to your bedside. And so his intensity matched my intensity, and I think he drew from that immediately. And that's really where him hit it off at the end. But I only discovered all that after I was done interviewing. Holy cow.
Yep, right? And did a quick Google search.
Right. After, I was like, who was that guy? And I was like, wow. And that was that for me, right? You know?
Well, so again, before we dive into, like, say, CRISPR, because I mean, you know, we talked about CRISPR quite a bit already, like offline, but I really want to I want to understand better, because I mean, say you really are like the 1% of 1%, right? Like most people do not make it to professional level of any kind of sport, right? So I'm really curious, like, what do you feel like is similar from like your mentality when you were, you know, playing ball to, you know, what you're doing now in biotech?
It's a great question, Jacob. I think, you know, and I've thought about this a lot. And if you humor me here, this is the best part. So
yeah,
in baseball, you know, in professional baseball especially, you're going to have a lot of things that are very similar in your routine every day. So, you know, you're going to play every day, 140 games, not including spring training. Every single day you're doing something similar. And so it's like Groundhog's Day, except for you're going to be in a different town. So you're going to wake up, you're going to have breakfast, and then right around 10, 11 o'clock, usually, you're going to get to the field, and you're going to have lunch, and you're going to do everything the same. And then you're going to do your stretching, your lifting, your warm-up, your batting practice, your routine before the game. You're going to put your jersey on the same every single day. And then the novelty is the game that night. And all the preparation that you've been doing, all the things that you've been focused on for the whole day, they all come to a culmination in that night to see on a nightly basis, you get this positive, you know, output, or negative, if you will, sometimes, on how you've prepared. And ultimately, I see this a lot like what you do in a laboratory, where you're going to be doing a lot of the same things over and over again. And the more consistently you can do those things in your routine, and the better you can make adjustments in experiments that might fail, say striking out as an example, then the better you're going to have, you know, the ability to be turning around and making an adjustment to be, contributing to your team, which is your laboratory's ultimate goal, which is to find the answers to questions that you're all collectively interested in. And so in the case of baseball, you're interested in winning, right?
Right.
And so you want to be able to contribute to that. And it is up to you to be able to learn from, what was successful, learn from what was a failure, and then take that novelty from the night before and quickly translate that back into an adjustment or to a concerted effort to keep doing the same thing, And so it's kind of like, don't talk yourself out of success, and also don't be afraid to face the failure of a hypothesis that fails, and recognize that ultimately it's all about being receptive to the science and taking the subjectivity out of it. It's like, if I objectively was swinging poorly for something biomechanical, I wanted to know about it.
Mm-hmm.
My experiment fails, or if something happens, it's not because it fails because I did the wrong prep work or whatever. I want to make sure I get a negative result. That's a true negative result. It's the same thing. And so being able to handle lots of failure, being able to focus your effort towards something that's collectively going to keep pushing towards the answer. These things ended up becoming very, very similar. And, you got to have a little bit of a loose screw in baseball to keep going up there. And, if you succeed 3 out of 10 times in baseball, and you do that long enough, you're a very well remembered baseball player. And so ultimately it's about recognizing what the failure can do to inform you of how to succeed. And that's a skill that can translate from either one.
I love it. Oh my gosh. Yeah, that's a ton of gold. I mean, I talk about this all the time on the podcast. I mean, really, everything kind of comes down to preparation in my mind, particularly, especially, I mean, everywhere in life, but I mean, especially if we're talking about sales or the business world, because I mean, if you can't control what somebody else is going to do, what somebody's going to say, what kind of questions they're going to ask, but you can control how much you have prepared and how much you have personally practiced, right? Like you were just saying with the baseball thing, like you can't control like what pitch you're going to get in a game, but you can control how many times you've taken, that fastball, that curveball, whatever the case might be. You can control those things to practice it and try to get it down to the point where, again, you are succeeding that 3 out of 10 times and you are a hugely remembered baseball player. Something I wanted to hit on was the value of experimentation. And I mean, I feel like you're kind of the perfect guy to talk to about this because you are experimenting all the time. Do you have any idea how many experiments you have run in your life?
Oh boy. A lot,
Yeah.
probably thousands, if not millions. I mean, because, I see experimentation as saying, what kind of bat do I like? What kind of, what's the grip, feel like? How do I time up a specific, pitcher or what's the adjustment that I need to make? Things like that sort. Like I had a batting cage in my backyard growing up, so that was a laboratory,
Yep.
I mean, for me. And I think that ultimately it was kind of like, you know, um, that cerebral thought process was always, you're always tinkering, right?
Mm-hmm.
Not necessarily in a lab now. You don't change an experiment once it starts. Some experiments run several days. That's not right. You can't change that. That's not how this works. Now, ultimately, though, it's about yeah. I mean, to answer your question, millions of times, and I think that it's sometimes scary for folks. I've seen this in science a good amount too. It's sometimes scary to make those adjustments because you don't
Mm.
know too much, you know. And I saw a lot of that at Berkeley. A lot of really smart folks that were really nervous about, they were waffling about experiments, and I'll keep it PG. But Teach would always say things like, "Just run the experiment,
Yep.
just do it." And ultimately, you're gonna have to do all of them. So you might as well figure out which one you want to do the most and just get going and execute. Because the faster you get feedback on a executed experiment, irrespective of what it is in your life, if you're in business or you're in science or in baseball, whatever, you're going to know more information immediately, and that's information that will arm you with a better choice down the road, and your tree of options and your game theory will improve. You
Mm-hmm.
know more faster, and it's not just to do it to go through the motions, but to execute it to the best of your ability, and to find those answers faster is something that really is powerful. And there's a cycle time on that for certain people, and if you can decrease your cycle time by making yourself more focused and to just get going, you will ultimately be more successful and you'll have an edge on folks as a result.
Yeah, 100%. I love what you're saying. I mean, this is you're preaching to the choir here. Said this is what I say all the time with like folks on my show, but it's in the podcast in general with my coaching clients, everybody I'm talking to really. I mean, it comes down to just, you know, I mean, I feel like don't let fear ultimately control you, right? Like let it like be afraid and do it anyway. And like I'm a big believer that, I mean, obviously, you're very much a man of science, so you might disagree with me a little bit on this, but I see like if you run an experiment, right? Like in the business world, trying out some new verbiage in sales, whatever it is,
Yeah.
and you ultimately don't like you have the hypothesis, I think I'll get this result, and you ultimately are wrong, like it quote unquote fails. I don't really see that as a true failure because, like you said, it allows you to iterate again, and hopefully version 2 or whatever, version 10, 100, whatever, will be better. A quote comes to mind, one of my favorites, and I can never ever remember who said it, but it's pretty short. It's try, fail, try again, and fail better. I mean, how do you feel about all of that?
I totally agree. I would argue that that's ultimately important, as important in science as well. I think that um, being afraid of failure simply means, that you're not ready to run the experiment. And I think
Mm,
that if you're not ready to run the experiment, you have to ask yourself why, right? And
mm-hmm.
I think that, if you understand these principles right here and you get in the flow of doing this, it's not so much about being fearful because you're not going to lose if you've done this right and you've prepared the right way to get there, right? No one who's ready to run a great experiment ever feels nervous about this outside of the fact that you might actually find out the hypothesis isn't what you want, but you can't control that, right?
Mm-hmm.
And so it's like if you're afraid of those things, then ask yourself why you consistently are doing that. And is it a reason that's founded in objective reality? Oftentimes it's kind of like, are you nervous because you don't feel confident for something else? Or is it something that's actually just holding you back based on the design, right? If you're afraid that someone's going to make fun of you or give you a hard time in business or whatever, then ultimately it's because it might not be the right investor or it might not be the right person or it might not be
Mm,
the right fit for you personally. And I think that you find out more about that the more you go out and try, right? So
yes.
you know exactly who's going to be receptive to your brand of pitch or of business or science, and that's like Tej as an example. He's a specific type of scientist,
Mm,
and it's been said time and time again that he's intense and he wants to be ultimately successful in science and he wants his folks to do the best they can because he wants them to get that excellence out of their work, and that can drive scientists away. And you know what? That's fine, right? But he's learned exactly which kind of scientists he wants to recruit as a result. So it's a perfect example of it. And it's like the more you do this, the more you learn about yourself. And I think that Teach ultimately liked me as a baseball player that to could turn to science because he knew that there was a lot of resilience there relative to failure, which inevitably is the case in business too. And so it's about learning how to just embrace the suck, if you will, right? I mean,
yes.
understanding that's going to happen to everybody, and everybody's not going to feel 100% all the time. You could never feel 100% playing 40 games of
Mm,
baseball a year. You can never feel great in the lab every day, but no one's going to care when they look at the data, right? And no one's going to know in the background. And so it's kind of like don't suppress your feelings, but also don't let your feelings control your decision making skills
yes.
relative to the business because objectivity is the place to be in business. If you let your ego and your emotions run your business or run your focal points that you want to get on touch on, you're gonna be ping ponged all around the place and you're not gonna really know, why you're not being successful. And it's ultimately because you're letting your external factors affect that. And I think that that's back to what you said a second ago, Jacob. It's focusing on, and I couldn't agree more.
Yeah. Oh gosh. Yeah. So you and I are on the same wavelength. Like the what I always kind of say, like the little glib saying that I always tell people is, like feel the emotions, obviously, but emotions, feelings, they are indicators, not dictators, right?
Yeah.
So I mean, don't. I mean, it's like you were saying. Like I mean, the gym is I feel like a really common example of this, where you wake up one day and you feel great about going to the gym, and so you go to the gym, and the next day you wake up, you don't feel like going to the gym, but you go to the gym anyway. And I think it comes down to like the stories that we're telling ourselves when it comes to this kind of motivation thing. And I think motivation is a feeling, but it's more a result. And it's like discipline, where like you don't remember that you didn't want to go to the gym yesterday in like a year, but you will notice that, oh, I feel better in a year, I look better in a year, I'm stronger, whatever the case might be. I love it.
Yeah.
Um okay, so I promised we were going to talk about science here and not just, philosophy and baseball and all the good stuff.
No problem.
Um, so the place I want to start might be a little heavy here, but I want to talk about CRISPR, CRISPR-Cas9. So you know that I've got a very, very little bit of experience with this, kind of, sort of, not like you, obviously. But for just like the folks listening at home that, I mean, most people have not heard of this to my knowledge, but what is CRISPR? Like, what does it do? Like, what is it?
So CRISPR originally, this is fun. So this is how Jennifer Doudna would tell you. She'd start from the beginning. She'd say, when we were doing this and we had this discovery of CRISPR technology, which is ultimately now a way of editing genes through a series of processes that were engineered through her lab and others.
Hmm.
When we first discovered it, it was a primitive immune system in the bacteria.
Okay.
So simply put, this thing was a protein, a gene that turns into a protein that turns around and scans the cell, the bacterial cell in this case, for invaders. And these invaders are bacteriophages. So little bacteria get infected by even littler viruses. And these viruses are a problem because they can actually insert their DNA into the genome of the bacteria. And CRISPR has these specific sequences, kind of like a library of them in a specific place that in the bacterial chromosome that it can use to detect whether or not there's an invader. And if it finds an invader, it is like a molecular scissor. So it'll
Mm.
go in and cut away the DNA and remove this sequence. And so what Jennifer and others, Emmanuel as well, what they figured out was that if you were able to use CRISPR the right way, you could actually program it to target other things other than these specific bacterial integrated viral sequences. And so they were figuring out that you could take this thing, this protein Cas9,
Hmm.
pair it with a programmed sequence that could target anything in any context. And in the human context, that means like in a cell, in a dish, you can take the Cas9, you can integrate the Cas9 into the cell with several different processes from
Hmm.
molecular biology and target a gene and then trick the cell into repairing the sequence of DNA in that region to something else that might be actually the normal sequence, right? So if someone has, for example, sickle cell anemia is a famous one because it's
Yeah.
got one sequence, one base pair different. You can actually revert back to that sequence and essentially change the cell's sequence of DNA in order to encode for a wild type normal copy of the gene that's encoding in these blood cells that would enable you to transport oxygen better. And so, the sickle cell is not as shriveled up anymore. It's back to its normal state. And that's powerful. And so you can do all kinds of things with this type of technology now. You can engineer drought resistant crops. You can actually do something called gene drive where you can affect mosquito populations that are carrying malaria. You
Mm.
can do you can use this in specific ways to use it for immunotherapy and cell gene therapy and cancer. And so it's a broadly applicable technology that allows you to manipulate DNA in creative ways in many different organisms, not just in a dish anymore, but in full-blown organisms from all the way to a human.
I love it. Oh my gosh. So I just want to kind of break this down just to make sure that I'm understanding what you're saying here a little bit.
Sure.
So you're telling me that, like, using like the sickle cell anemia example, right? So if somebody has sickle cell anemia, you're saying that they have, just I mean, it's a very small sequence. You said there's a couple of sequences different from like the proper way it should have been, right, in their DNA. So they take this treatment of CRISPR-Cas9, however they take it and that will alter their DNA so that they are actually a healthy person again. Is that, am I
Yeah, so in
understanding
the
that?
case of sickle cell, the concept is simple because it's carried in your blood and it's a single base paired change, small
Mm.
sequence change. There's less risk that you're going to introduce something that's very problematic because it's large. And so, um, you know, what I will say as an ethical scientist is, we're still working out all of the kinks on how to do this thing at large scale and inside of
Right.
this the side of the body. In the case of sickle cell, you can actually take out someone's blood cells and engineer them ex vivo outside the cell, outside this, well, not outside the cell, but outside the human.
Yeah.
And then you can take the cells in the dish that have been engineered and properly sequenced and confirmed to be now what you would desirably want them to be. And then you can transfuse back into the patient. And because these are the patient's cells themselves, you're able to actually engineer this so that you're not causing the immune system to be inflamed. And this set of cells that's just been introduced back into the system, they can populate and they can go through mitosis, things like that. And so you have the ability to consistently treat a disease that would otherwise be genetically encoded with engineering outside of the body to go back in. And that's a lot less risky than just to engineer something where you're putting CRISPR directly in.
Hmm.
Um, because, things are still getting worked out in terms of the efficiency. And that's, if you were listening to Jennifer or Emmanuel or anyone on that, in that sphere still, there's a very, very careful call to ethics. And, granted, I'm not the person who's always doing the editing myself. My company and my focus is on helping folks get the right tools in place in order to do this. And so if I've misspoken on any of that, I'm sure there's probably new ways to do things that are always evolving. And, ultimately it's just trying to bridge the gap between the folks that are out there in the world that want to hear about this and the folks that are in that space doing it. And it's important to note that when I say there's lacks of efficiencies and things like that, that's why we're not doing germline editing. That's
Hmm.
illegal, worldwide stoppage on that. No one's
Yeah.
doing anything like that. These are cures for diseases or for pathology that's associated and attributed to somatic tissue, non-germline, non-reproductive. So we're not changing the inheritance. You're not inheriting designer genes. You're not doing this in a dish with human embryos. So it's important to note that a lot of folks talk about the ethics behind this, and it's premature in my opinion. I think it's important for people to understand that even if we could do that, should we? That's a
Yeah.
question, but we're not there yet.
Yeah. Yeah. Which, I mean, I think it's hugely important because, I mean, this is, like you were saying, that's why, like, the bacterium piece is so critical because, I mean, that could get, I mean, it could get dangerous pretty quickly depending on whatever people are doing. But I mean, I think it's important to just for people to be somewhat aware of this because, I mean, is it safe to say that CRISPR to some degree is kind of the next thing, right? Like for the
Yeah.
next 100 years, like this is what we're going to be, experimenting with, figuring out how to do, like I said, more efficient or just in different ways. I mean, is that safe
Yeah.
to say?
Yeah, I mean, Vertex Pharmaceuticals, I believe, is the first one that just had an FDA approval for a CRISPR genome edited focused therapy.
Okay.
So there is an FDA approval already. That just happened within the last year. There is no alternative way in order for us to go forward with genetic engineering that's more efficient or better than CRISPR, although we have still a lot to work out. And it's also important to note that it's not just Cas9. There are all these other CRISPR-Cas systems.
Mm.
There's Cas12, 13B, 9, of course, different versions of 9. There are several different ways that people have engineered this for efficiencies and to safeguard against off-target effects from this, things like that, right? And so it's going to be here to stay. And in this type of technology and the concept of humans using this for enabling the human condition to be improved is not going anywhere. And that's because of a lot of our therapies from the past are imperfect. Not that CRISPR is perfect, but it's more perfect
Yeah.
because, when you use a chemotherapeutic cocktail, it's like essentially saying in some cases that you've got one tree in the forest that's not so good and you want to
To
get
kill
rid
the
of it, but you're
forest.
going to light the whole forest on fire to
Yeah.
do that. And so we want to become more perfect and more precise in our ability to engineer therapies that are for humans and then do that in a more personalized way because not all folks have the same genetic backgrounds.
Hmm.
And as just as unique as everyone's genetic background is, so is cancer sometimes in many cases. And so in order for us to be able to better treat folks um, collectively, we need to become more precise.
Yeah. 100%. Well, and I'm hoping that you'd be willing to speak a little bit more to the ethical piece of this because I think that's because, like I said, CRISPR and just in general, I think it's just kind of a crazy concept a little bit, and I think the ethical piece is really critical because, well, if you'll forgive me for quoting Jurassic Park, sometimes I think you might know the line I'm going to say here, but sometimes we worry more about if we what is it if we
Instead of we
could,
should.
yeah, if we should.
Yeah.
So I mean, yeah, could you
Ian
just
Malcolm had
explain?
it right.
Yeah,
Yeah.
yeah. A
Yeah.
little more of the ethical piece of this, like what does that look like right now, and like where do you think it's going to go?
Well, I believe that no one has better articulated this than Jennifer herself.
Hmm.
I think that it's very important to look and turn around and say, in the face of all this fame, the fame and the excitement about CRISPR, Emmanuel and Jennifer, especially because I was at Berkeley a lot during all this, she's been very outspoken about making sure that the technology is used in an ethical way.
Yeah.
I just said that there was a um, haltage or a no-fly zone for germ editing in germline editing in humans, and that's because that is an ethical thing because you're changing the course of history by changing someone's genetics, which will be with them forever if you pass those down.
Yep.
Ultimately, there's other ethical parts to this too. If you're talking about something like gene drive, where you can effectively change the mosquito populations in certain areas in the world, or that can affect ecosystems and that can cause all sorts of collapse. And
Mm.
you have to be very careful about that. I think the answers to these questions and the answers to all of this is that scientists must always continue to communicate every bit they can
Yeah.
to everyone, because as it comes up, we learn more and more every year, and it's becoming more and more complicated. And because it's complex, and because we don't understand all the answers all the time, not even close, um, it's going to become even worse for folks that aren't in that space all the time.
Mm-hmm.
I'm certain that I haven't looked at all the literature that's been out there recently about new improvements to these types of technologies or the new therapies that are coming out. How could I? Anyone couldn't do that all day, every day. And so the the public that's not in science, it's not that folks are not able to grasp this. It's that the scientists need to be able to continue to communicate complicated things in a simple way,
Mm-hmm.
but it's understood as to why that's happening, because scientists aren't the only ones that can have control over the ethics of this. We all need to have continuous conversations about this. And if people don't know the rules of the game, then I think the ethics are hard to have a discussion about, right?
Yeah.
And I think that, knowing and understanding the power and the capability of CRISPR-Cas9 as an example, as it relates to the success rate of a genome edit, is something that we don't ever talk about. We talk
Mm-hmm.
about the ethics all the time, but I think that it's important to know if the ethics are at question, then we should also know, more about the success rate. So it's like exactly how you said, could we? Well, could we? Yes. But how many times is it going to take before we actually successfully do it? I don't know. And is that detrimental to the human? If someone is someone suffering because a therapy needs to be successful before it gets transfused back in, and we don't have the ability to do that, and that person's taking a CRISPR, based therapy like this, when they could have taken a cocktail of chemotherapeutics that would be obsolete, but give them a chance to survive faster. That's a question we need to think about, right? I mean, I think
Mm-hmm.
all these dilemmas with these things, and an oncologist's job is getting more and more complicated because bedside manner is filled with these types of juxtapositions. And if someone's emotionally charged up because their loved one has cancer, for example, how do you parse through that and explain that to somebody? Is there ethical problems with giving them a therapy that might be more precise but less efficient
Mm-hmm.
relative to something that could be more detrimental but more successful? It's hard to know. And so, you want to give people more information and less than rather than, too little. And there's a side of that that's ethically problematic too, because, if someone's gone through the training and the exercise of understanding why they've decided to give the therapy to that person, the answer can't just be trust me, right?
Yes.
It has to be some sort of, halfway ground so that everybody understands why the doctor's doing that.
Yeah, 100%. When I think you said like the bedside manner piece, like that really kind of hits home because ultimately that's where these things will land, right? Like we can talk about all the millions of billions and hundreds of thousands of whatever experiments that are run to figure out these kind of treatments and these kind of therapies, but ultimately it comes down to, let's say, that like the doctor sitting next to you with your loved one who has cancer or whatever else it might be, and trying to explain these very complex, very difficult conversations where, like you were saying, it's you're trying to compare like, well, one's more efficient, but you're going to have X, Y, and Z. Like you're going to struggle with all of these kind of other side effect things, and it's a really really difficult conversation. And I mean, I one that I like you said, like you and I probably aren't going to solve all these issues today,
No, but I mean,
unfortunately.
diagnosing them is important.
Yeah,
Absolutely.
100%. Like I said, having these kind of conversations, I think, is really really critical. And having the conversations between like folks like yourself that are extremely well versed in these kind of topics with somebody like me who's maybe not quite so much, to help get the word out a little bit and help people to understand a little bit more what's happening in the world, particularly on cutting edge science. But I want to pivot here a little bit because you and I were talking, off air, about some of the things like when it comes down to science, where you're kind of mentioning where some folks think that you have to go to like certain kinds of schools in order to achieve certain levels of scientific discovery or scientific experimentation. Can you just speak to that a little bit more?
Yeah. So in my own journey, I went to Berkeley as an undergrad and
Mm,
experienced a lot of success in the lab. And the thing about working in high profile laboratories at Berkeley is that you meet incredible postdocs and PhD students, and the postdocs, in my opinion, were just incredible there. And that's because they were the top of the top of their PhD programs. They
Mm.
crushed it with their ability to do great science. And so it was interesting because, those folks become professors and they go on and they do great things. And oftentimes, in my case, the folks that were in my cohort in the lab were they went to the Ivy League, they went to MIT, they were Johns Hopkins for
Mm.
professors, and that I was asked by a couple of those folks, one of those folks particularly, to come and work in the Ivy League as a PhD student for him. And I ultimately was already committed to the University of Montana at that point, and I wanted to be here for my own family and for other familial stuff. And it was really it really at that point dawned on me that I believe I can do good science anywhere. And when I got to the University of Montana, it was still the case, and I knew that, and I was successful because of a lot of the training that I experienced prior. Um, but what I really noticed wasn't that the difference in caliber of students was anything specific. It was
Hmm.
it was actually the ability to realize that their impact or their ability to change and impact the world was, in their opinion, different because they were here rather than at, say, Berkeley or at Harvard, and I realized quickly that it wasn't necessarily that people weren't as good. It was that they didn't believe as much sometimes. And I think
Mm.
that what ultimately I tried to do was champion confidence and realization that we can do good work anywhere
Yes.
and anyone can. And it's about being resourceful and, you know what, ultimately reaching out and trying to talk to folks. If you think there's somebody at a school somewhere that you can call on to help you and collaborate with, ultimately it was a surprise anytime I said, well, let's call the teaching lab. They would work with us on this. It was always sign of, in the beginning, it was surprising. I had many folks that were like, really, they do that? I'm like, yeah, they love collaboration, right? And that's why Berkeley is Berkeley, is
Hmm.
because everybody's working together all the time. I mean, the amount of support that a faculty member who's up for tenure receives when they give their tenure talk at Berkeley is incredible. The entire department, hundreds of people show up, professors and postdocs alike, and there's this rich conversation about the science because everybody's excited to have that person among their ranks for the rest of time at that point.
Yeah.
And I think that ultimately we champion that at University of Montana here. We just published a paper that saw us go across, I think, 4 or 5 different departments with a range from hardcore geneticists who are working in fruit flies to hardcore structural biologists that are working on trying to solve nasty structures of things that were for neuroscience purposes.
Mm.
And all the way to genome editing. And we used folks that were from biochemistry background all the way to the genetics to do these experiments. And the paper has been well received because of the range of folks on it. And I think that it's a testament to how any department anywhere in the United States that is you know known by anywhere can do great work. It does not matter where you are. I would say that the faculty at the University of Montana, as an example, are sneaky good. There's a lot of folks from really good places, and I think that the students are coming in, and it's already daunting to do a PhD or a master's program or either one of those, right?
Hmm.
And it's like, don't feel like you have imposter syndrome that overpowers your ability to have some confidence, because once you learn something, in the beginning you want to be receptive, but once you learn something about something, it's like, how can I take what I've learned here, enhance it, and better collaborate? Because out there in the world, we're more connected than ever now. I think COVID, everyone shut down for COVID, but we
Yeah.
all stayed connected. And I think that it's really important to recognize that, there doesn't need to be a pandemic to reach out via email. There
Hmm.
doesn't need to be this barrier mentally for folks at these schools to try and do good work. And I think that, ambition is something that should be universal.
Yeah. Oh gosh, I love that. I love that. Can you just explain a little bit more to me? Like, what do you mean, like, when you say like doing good science?
Mhm.
Like, just like help me understand that a little bit better. And then,
Yeah.
if anybody out there listening is maybe they're an undergrad or maybe they're thinking about going back to school to pursue like a PhD or something, right? What kind of advice would you give to those folks to say
Mhm.
like, hey, I'm thinking about going to maybe some of these less prestigious schools that you wouldn't necessarily think about as going for like your PhD in biology or whatever. Like, what should they be looking out for?
So for example, my PI, the professor I work for my PhD,
Yeah.
She's incredibly gifted as a scientist. And, her postdoc training was at Johns Hopkins, um, with Geraldine Seydoux, who's one of the most reputable, famous worldwide developmental biologists in the world.
Hmm.
Katya is her name. Katya Vornina was my PI here at University of Montana. And, um, Katya, as an example, has her PhD from Brown and then her postdoc from Johns Hopkins. I think one thing that I'm telling everyone out there is if you look for the scientists rather than the school,
Mm-hmm.
they will be there, right? So,
Mm-hmm.
Katya chose to be here, right? She was competing with folks in her own cohort from postdocs that, she got the job here, but they got a job at Dartmouth. It doesn't matter, right? And so my point is that, there are wonderful scientists everywhere, and they will match the intensity of what you want. And by doing good science, I mean simply don't fudge your data. Don't do stupid things like that.
Yeah.
Look for rigor and look for no easy way out, right?
Mm.
A challenge for folks at schools where there's less funding is we're going to have to find ways to cut corners, if you will, not like necessarily, you know, finagle it, but ultimately try and do a cheaper version of something, right?
Mm.
And if you have a certain type of technique that's not offered broadly at your school, or if you are wanting to bring a technique to your school or even collaborate with someone that has that, reach out because it can enhance the data that you have currently and enable you to do something else that you have access to immediately that ultimately wouldn't have been informative until you have that extra data from something that might be less accessible to your school. And so, by doing a collaboration with someone who has a fancy microscope or some sort of technique that's been pioneered and championed by some specific person, you actually are getting more information for your own work. And it gives you the ability to be a bit more scientifically creative relative
Mm.
to the question. And so, by doing that, and by also saying, look, we don't need to constantly change direction on something because we saw one negative result. Understanding when and when not to say no, is important. And I think that it was fun because Katya and I both grew so much during my PhD. She's a wonderful PI, and I have a big personality compared to a lot of the folks that she had in the lab, and the intensity that I bring from my former time at Berkeley, it took some adjusting for her and me,
Mhm.
and I think that ultimately I wouldn't have traded that for the world. I mean, there were times where she would say too, oh, you were frustrated by that. I'm like, yeah, I was frustrated by the situation because we wanted to do more and we couldn't, and we had to find a way, and that was growth that I needed because
Mm.
I was on the top of the list with respect to funding at Berkeley. And, it taught me to be a resourceful scientist. And, when you are resourceful, you can still do great work. I mean, we just published our paper for some of my work in Nature Scientific Reports, and it's getting a lot of attention. Um, I think that there are better journals out there based on impact factor, but if you're reaching a lot of people and people are accessing your journal publication, it's a testament to how much of the quality of the work can reach people and people want to read it, And I think that
Mhm.
that can be done anywhere.
Oh, I love it, man. Well, there's one thing that I want to make sure we touch on because I feel like it could be easy to. We're talking about a ton of great, great information on the sciences and everything, but I don't want to overlook something I think you said was really important. And it's essentially what I think you're saying is coming down to networking, right? It's where you're talking about this collaborative, culture, I guess, that can happen a lot of times in schools, but then also just across the sciences and across schools too.
Mhm.
And I think you said like, hey, if you're thinking about collaborating with somebody or whatever, then shoot them an email. Like if they're busy or if they can't do it right now or they don't want to, they'll probably tell you, right? But I think, and correct me if I'm wrong here, but I think something that folks like myself that are more in the business world as opposed to the sciences that we could probably learn from folks like you in the sciences is that when you guys are reaching out to collaborate, you guys are probably very specific, saying like, hey, hey James, I'm working on such and such. I think that you and I make sense to work together on this. Here's why. Here's what I think you could contribute. And so often in the business world, we just like reach out to somebody like, hey, can I pick your brain for 5 minutes and hope for the best? Is that fair to say?
Yeah, I mean, I'd say that, there's a line. So it's a little bit of Goldilocks, right? So when you're
Mm.
reaching out to somebody in science and, in business too, we do this as well. You want to understand it from their perspective. It's about being receptive and empathetic to the person that you're trying to reach out to. It's like if it was me reading this from you, right? What would I want? And what I like to do is I like to say, here's the topic, here's what we're talking about,
Mm.
but don't do too much detail right away. That's scary too, right? I think that by saying too little, you might be showing them less confidence than you would like to, because you're saying, hey, I'd just like to talk to you. It's like, well, do you have a plan on what we want to talk about? Right? Because a lot of folks that you reach out to are generally, in business especially, are folks that are really, really, you know, valuable to you, and
Yeah.
their time is valuable. And the idea here is, if you recognize that that's the case, and in business sense, for example, you
Hmm.
have to say, look, I acknowledge how valuable your time is, and I know why I want to reach out to you, and here's why. And it's okay if you've got no time for that. I just definitely wanted to try, because worst case scenario, they'll say no. But if you say it in a way that's like, hey, I get that you're busy. I understand that you're busy, but I want to talk to you about this, this, and this. And that's because you've done your homework, and you are intentional about that.
Mm.
That shows them that there is no ego involved in this, or there is no hope, wish, and prayer that the right thing will get said on the call, or the right thing will get said via email. And it's more about what you really want to talk about. And I think that shows some confidence without sounding too confident. And I think that folks that are, and you've respected their time.
Hmm.
I think that business folks, there's this worry that if you sound unprepared by stating what you don't know, then you're less likely to get the meeting, right?
Yeah.
In reality, if you don't show them enough, and you're a bit more vague about what it is that you want to talk about, ultimately that shows less confidence. And I think that, the confidence piece of this is important, but you know, it can't be overdone, and it's a Goldilocks thing for effect for that.
Yeah.
Um,
Yeah.
yeah,
100%. I absolutely love that. Where you got it, like, again, it comes down to intentionality. I mean, intentionality and experimentation too, right? Like, you can't just throw something together at the last minute and hope for the best, but like, you can't just, spend all your time preparing either. So you got to be intentional with preparing enough to get something done, to get enough result that you actually learn something so you can do it again, right?
yeah,
Last couple of questions here, Jimmy, as we kind of start wrapping up our episode, as we were talking, off air, we were talking about just like pitching a business a little bit, and like you were kind of mentioning it a little bit a minute ago, but like, just like, how did you pitch some of your stuff? You were talking about some of those things, and then really trying to, I guess, empathize with the folks you might be talking to actually tell them the things that they want to hear.
yeah. So I had an unconventional way that I've shown my company to folks. I don't even know if I would say pitching, because nothing about it was by definition a pitch.
Yeah.
Um, and so in my industry, in biotech, in my sector of biotech, even, data is king. And, I think that what I really want to say before I say anything about that, though, is more of something about general presentation of your company. If you want
Mm.
to call it a pitch, call it a pitch. It's that my biggest recommendation is to focus intently on product always, right? Everyone says that, but the idea here is, if you say more about your product and not less, even if your product is imperfect, you can have the answer back, to them about what their risks are
Mm.
relative to that, ready to go. And that's showing preparation, and that's showing there was an actual plan in place, right? I think that too many folks are too scared to disclose what hasn't worked or what could not work, and they get stuck in that. And
Yeah.
then, an investor will eat you alive with questions if you're pitching, right? So, in my case, I had a product ready to go, and my product was backed by data, right? And to be honest with you, I didn't really have a pitch deck. I
Mm.
never used a pitch deck. I never had a business plan in place. I said, here's what we're going to do. Here's what we're focused on. And then as we go, this is how this will evolve. Because in my world, in biotech, things are very dynamic.
Right.
You have a plan. We have a business plan now. We've clearly got a series of focal points: Q1, Q3, mid, long term, short term, everything, right? Um, but it grew out of a place of excitement around the product. It didn't even matter that we didn't have anything, you know, uh, perfectly set up on a VC style pitch, right?
Hmm.
It was more about showing this product will enable us to do X, Y, and Z, and here's the excitement, and the excitement there opens up an infinite number of vertical market options for us, and that right there allowed me to be dynamic relative to the pitch, because then people would ask questions about this or that, and I would say, yes, we have thought about that, and we've gone that way. So ultimately, it's not that I wasn't prepared with a pitch deck. It was that I was saying to them, I'm not going to daisy chain and pigeonhole myself into one specific area.
Mm.
That's how you get a one-track mind on this. And if you're building a company from the beginning, you can easily shelf yourself out. You can ceiling yourself out because you've put yourself in one category that never will ever go any further after a certain point. And that's a risk to an investor too. And so what I'm saying is it's almost like in the beginning of this, when you're looking for like your seed round,
Mm.
you will go pitch to people without as much preparatory material, because you never know what they're going to ask. And pitching is about intentionality and excitement about your product.
Yeah.
The amount of times people got excited about the product and the confidence that I brought about it because it was backed by data completely outweighed and completely overshadowed any necessity for the formalities relative to VC style pitch decks or
Mhm.
funding, budgeting, all this stuff, right? Like, because it's such an early phase company thing. I think that now what I've seen more than anything is that anytime I've shown more material rather than less material, they don't care. They want to see the product focused on the right places. And maybe that's incredibly unique because what we do at my company is a unique space. But I mean, everybody's trying to be unique. So I don't know how actually specific and special that is to my situation. I think that if you are confident in your products and you're confident in your strategy and you do not pigeonhole yourself as much, you can really captivate your audience in a way that conveys the excitement that you have about what you're doing. And
Yeah.
that's more contagious than a VC style pitch deck. And that's really what's going to sell them on it rather than slides.
100%. Like it really comes down to like if you know what you're talking about, right? Like,
Yeah.
I mean, if you're excited about the thing, be excited about it. Show them why, and then like you said before, if you don't know an answer to it, or you're like, oh man, we haven't thought about that yet. Tell them that. Just tell them
Yeah.
like, and tell them, hey, we're open to considering something like that. I
And that
mean,
point right there, a lot of
yeah.
people, they don't know. And that's the key right there. Jacob, if you focus on that and you say, I don't know, but here's an option and here's another option, you actually give them some imagination with you, right? It makes
Let them
them
see the vision.
strategize with you, and it makes them feel like they're part of this already. And that right there, that openness to say, I'm not sure, but here's an option. Here's an option. We've thought about this. What do you think about that? And it's like, look, people are going to say no. People
Yeah.
say no. And it's like, if they say no, does it matter? No. You're going to learn something from that. And by the way, you can rope people in after the fact because, I've been thinking about that. I would like to think about this more with you. I mean, I think that folks across the aisle, VC style folks, they want an exit eventually at some point. They want answers, but like they're still humans, and you need to go to venture backed funding instead of an angel investment. You can still get them excited about this, and you can actually extend your runway of time before they start asking for an exit, simply because you've gotten them excited in the journey and the process itself. And that'll give you a bit more time to develop your product further if you need to, or to switch gears if you need to. And one thing that's important about all that is be transparent. Say all that. I think that business folks are scared to say stuff, and it's like you look worse when you act like you don't have an answer, or you don't want to talk about an answer in the moment, instead of just being honest about it. Just say the thing instead of don't say the thing. And it's amazing what happens when you do that.
I love it. Oh my gosh. All right. Jimmy, thank you so much for coming on the show today. We have really run the gambit today. We've covered, business, baseball, CRISPR, all kinds of fun stuff. Last couple of questions here. So, if anybody wants to connect or get to learn more about you, where can they find you, and what's kind of on the horizon for your company Arctos for 2025?
Yeah, so you can go to arctos.bio. That's us, ARKTOS.bio. And at the bottom, it says, tell us what you need. It's pretty simple. You click on it and you can send us an email. What we're focused on is, we're an early phase company too. We're a young company, but we've made a lot of traction relative to a quasi manufacturing, focus point. I think the best way to put us is that we are a quasi contract manufacturing organization. We focus on very, very challenging targets. We do sell Cas9 and CRISPR-Cas system products. Those are challenging because of how hard they are to purify. Our focus in the rest of this year is to ensure that the customers that we have are met with what they want relative to their initial requests, because some of these are challenging targets, and we want to make sure that they have enough time and to validate their products. But then ultimately, we want to make sure that we're not scaling too fast. We've been really amazed by how much traction we've gained in this short period of time. And that's just because we've reached out to folks and we've been very intentional about who we want as customers. So if I make a protein for you, we want to make sure that it makes sense for the scale that you're going to be at. And for us to be really effective, we've kind of learned a bit more about where we fit into that market, which is larger place than where we thought before. Meaning that the companies that we're working with are a bit larger than we anticipated, which is great. We're really, really about right now focused on making sure that it's one step at a time. It gets overwhelming when you have so much going on in a business early. You want to do everything, right?
Yeah.
Well, you want to make sure that you don't do everything all at once. You want to be very, very focused on the next stepping stone. And, as much as it is important to have, insight into, what you want to do in the future, you have to make sure that you still get the wins currently. And so right now it's just about making sure that the team is and me personally are always aligned with what's the next step. And we've got a, series of plans that are long-term, but that long-term series of plans for contracts that'll run for years must be solidified by short-term focus. And so the way that we have allocated our time is, 75% focused on the current and then 25% of the future. And that might change a bit as it goes. But I think that shift and early phase companies needs to consistently every week in some cases be looked at.
Yeah.
It's like, how much time am I investing into the future without fortifying the present? And if the present is being too much too fortified, right? Then you don't have a growth, plan for the future. And so that's a juxtaposition all the time. And I think we're staying focused on getting some of our early phase contracts completed, which we have been on time, and ensuring that the quality of our products is always there. Because we're a younger company, we want to make sure that everybody recognizes that it's going to happen over and over and over again. And we're going above and beyond to ensure that at the moment.
I love it, man. I love it. I feel like you're kind of talking about working in your business versus working on your business, right? I mean, we've talked about it on the show before, but to Jimmy, thank you again for coming on. This has been an absolutely fantastic conversation. Thank you again. And thank you guys for joining us on this episode of PDP, and we will see you guys next time.